All right, we are recording now, and this was my graded do now.
So are you recording?
I'm recording. Didn't I?
Jay.
Oh, Lord.
Hi, Stella.
Now we got to start over.
Now I got to start over,
Oh, what? Leave it.
and I got to delete all this.
What?
I can go back and I can edit all the audio. I can actually have the picture there, and I can just erase the audio for what I don't want them to hear.
I am offended.
I'll leave it if you behave. All right, so here are 3 problems for a do now. And B-Day, you're supposed to pause your listening and do those 3 problems. Because I'm going to pause and I'm going to solve them and not show you, you'll probably see the answers. Because I think it still shows. What it does is if I'm not recording, the slide will come up and it'll just fade real fast. All right, so, they're going to see it on YouTube, so they're going to pause it. They're going to cheat. Let's put it that way. All right, what I didn't say was all 3 of these were right triangles. And every one of them had a missing x. And the first problem, I'm looking for an hypotenuse. So I'm going to set up the formula one time. Help me out. If it was a generic triangle, and habit always makes the legs A and B, the sides, and the hypotenuse always C, but it doesn't have to be, but this is pretty traditional. What's your formula? This came up in college algebra, so I didn't think you wouldn't know how to do it. But I was hoping that some of you would see some relationships, not necessarily with the first one. You're just going to have to plug and chug and do it all out. So A and B are my legs, right? So the first one, this is the first problem. 12 squared plus 15 squared was equal to C squared. And if you want to solve for C, you're going to do the square root of both sides of 12 squared plus 15 squared equals to C. Normally we say plus or minus. Give me one reason why I won't now.
Because we don't have a negative length.
Yes, the hypotenuse can't be negative. So don't worry about plus or minus. And so what is the square root of, what is 12 squared?
144.
144. What's 225 equals to C. What's that sum?
369.
369 equals to C. Is that a perfect square, 369?
No.
It's not. Can anything go in it? Can 4 go in it?
It's 3 and 1.
4 can't go in it. Can 9 go in it?
Yes.
Well, 9 goes into 36.
3 and 1.
3 times, 4 times, 9 times.
41 times.
Say it again? 9 goes into it 41 times.
Yeah.
So what I'm getting to is that this is actually the square root of 9 times 41, which would be the square root of 9 times the square root of 41 equals to C. The best answer, I was just talking to a student who just asked, is the best answer would be 3 square roots of 41 equals to C. But what if you just keyed in with your calculator? I didn't tell you how to give your answer, did I? Give your answer with 3 decimals. So C could also be approximately, give me 3 decimals. That's if you would have done it from what if you did it right here from the first step? Could you have done it from there and jumped from there to here?
Yeah.
Yeah, you could have. I didn't tell you you couldn't. What is that?
19.209.
Point what, 09? And I want you to do 3 decimals. Why?
More specific.
AP Calculus always wants 3 decimals. I'm preparing you for a test that you're not going to have for another year or so. But, and there's nothing holy about 3. Trust me, the science class does it a lot better than that. They have significant figures. That's even better. But anyway, there's the first question. Now let's look at the second one. We're looking at this one now. This problem right here. Is there a way to have done it without doing any work? Did anybody think of anything right away? Say it again. You recognized it. I mean, I sort of helped you, right? I put a 30 degrees here, and she's absolutely correct. That would make this a 60. That would make that a 90, of course. So knowing that, Does that help you know the answer? Because I didn't tell you how to do it. Do you know the answer without doing it?
Yes.
Say it again. Square root of 3. So she knows what a 30, 60, 90 triangle is all about. That if you had a 30-degree angle and the opposite side to the 30 was a 1, then the hypotenuse has to be a 2, and the bottom side here, which across from 60, had to be the square root of 3. If you did it with Pythagorean theorem, did you think about it and say, I think I've seen those numbers before? I hope a couple of you did.
So, 30, 60, 90, triangle, 45, 45.
Oh, you caught this next one, Miss Rodriguez? So without even thinking, you think you know the answer to this problem right here? She says it's a 1. Because that's the rules for a 45. If that's 45, then this also has to be 45 degrees. And the answer has to be 1. So I'm glad I at least have 2 people in here who learned from their geometry. Because I know you had this in geometry. It is a big deal when it comes to trig. Not necessarily today, but the next lesson for sure. All right, let's move on. I didn't care how you did them. If you knew the answer, fine. If you did all the Pythagorean theorem for all 3, fine. The first one, you could not memorize the answer. Never in a million years would I have guessed that answer. All right, we are in lesson 2, and look at all the wonderful things that we're going to talk about.
Wow.
Trig functions, the hard word that I can't say, quadrantal angles. Those are those angles, remember, that were on the 0, 90, 180, 270 from the last lesson. Reciprocal identities. This is pretty deep for being the first lesson of trig. Signs and ranges of function values, domain and range and stuff, and are they positive or negative? That's pretty deep. That sort of makes me mad that they threw that into the first lesson. Pythagorean identities. Well, you've already got an idea that a squared plus b squared equals to c squared. So I wonder how that becomes an identity. We'll find out. And then quotient identities. There's too much in here for one class setting. There's a chance that I may change my mind and make it 3. I don't know. Let's see how you do. You'll be the guinea pigs. Whatever you get done, then B-Day is going to have to do it too, because we are recording.
Let's do it all.
Let's do it all? All right. Moving on to the next slide. I don't like how they put this picture in quadrant 2. I would have been more comfortable if we'd have stayed in quadrant 1. And this is quadrant 3, and this is quadrant 4. So what I'm going to do, I'm going to put the exact same picture in quadrant 1. So I'll go over here into this side here. I'm going to draw the quadrants. This is my x-axis. This is my y-axis. I'm going to draw that same picture that he just goes out and he makes an angle. And if you look carefully, he does make this a right angle, right triangle. And he labels these values here. He says this is your x value. This is your y value. What did he label the hypotenuse?
R.
R. All right, except for Danielle right now, because she's had the class. Who else can tell me why is he using R? And if nobody gets it, then Danielle's going to take the steal.
So pretty much reflected it.
Okay, Claudia,
Is it the radius of the circle? Because it's a 360.
make a note on your paper and circle it and star it. I knew you were going to know it, Danielle. Danielle, put it on your paper too. I'm not going to rip you off, but I did want to give a chance to somebody else.
Well, I mean, I knew.
So
Probably like start everyone.
So here goes. Yeah, I know. Here is technically the circle. Oh, that's terrible. Let me do it again. I wish I could actually make a circle. Oh, that's not bad. That's not bad. Oh, I messed up here. Good enough. She's absolutely right. It's talking about a circle with the hypotenuse being r. And it didn't matter if you went this side or you went over here. It's still the same circle. Still the same circle. That triangle can move all the way around. You can put a triangle anywhere you want. Doesn't really matter. Matter of fact, let's be honest, that point here, that point can go anywhere. It could be over here. It could be here. It could be here. You can make a triangle anywhere. Look there's a triangle here. See? There's one there. And they're always drawn to the horizontal. Standard position, remember we talked about the horizontal line is very important. In other words, the angle has to go around from this side here and go all the way to here. And so that's why you're always measuring from this horizontal. Moving on here. Now that you have this circle, let's use Pythagorean theorem. You know that x squared plus y squared has to always be r squared. Doesn't matter where I draw it. I don't like over what he did because tell me about x over here. Tell me about it. I'll let Danielle answer this time if she can say something. Tell me about x. What makes x different here than it was over here?
It's negative.
Thank you. Very good. You add points. What about the picture I drew over here where I drew the green angle down here? Tell me what's changed. Put more points for you. This actually is a negative x value and a negative y value. Those are very important, guys. To know what quadrant my triangle is in tells me a lot about creating my numbers that I need. There's a big difference with saying something's a 5 versus a negative 5. Even, not with Pythagorean theorem, because it's still going to come out the same. He's not wrong. He's not wrong. You're still going to get r is the square root of x squared plus y squared, because even if x is a negative 5, what happens when you square it? It still becomes positive. So he's not wrong, but I want us to pay attention to what quadrants we're in. It may not be a big deal yet. So x squared plus y squared is r squared. Hey, that's a circle. Hello. Haven't we seen that before? The equation of a circle centered at 0, 0, radius of 1. Well, radius could be anything, because I could solve this and say r equals to the square root of x squared plus y squared. I could also, just to remind you, divide everything by r squared. X squared over r squared plus y squared over r squared equals to what? Remember that? I'm just relaying something from chapter 10, which will be on your test. You guys taking your test on Thursday on chapter 10, lesson 1, 2, and 3. B-Day's taking their test on Friday, lessons 1, 2, and 3. Okay? Pardon me?
Next Thursday?
This Thursday.
Oh, this.
Yep. Next time you meet,
Wait.
you'll be taking a test.
Oh, is it
Today's
Taco
Tuesday.
Tuesday?
What's that?
Oh, I was trying to figure out what day it was today.
Today's Tuesday.
Taco Tuesday.
I hope so. If there's a God, there's got to be tacos somewhere. All right. The question is, I had a great taco this morning. My wife made me fresh machacado and egg. She only let me have one corn tortilla. I don't know why. She said something about, you don't need another tortilla. Okay.
For the past 3 months, every Tuesday, my family has had Taco Tuesday.
What kind of tacos?
Like,
Carne picada?
huh?
Carne picada or hamburger? Beef steak? Beef?
It's
Chicken?
like- no, just like Taco Bell tacos.
What kind of meat is in it?
Beef? I don't.
Yeah, it's like hamburger.
Yeah, I mean, it's ground beef.
Yeah, ground beef. Same
Yeah,
thing.
It's
Yeah.
like,
That's carne picada.
I'm sorry, I didn't know that.
Oh. What's your last name?
Kano, it's Jewish.
Oh, sorry. Didn't know it was. You had mentioned something about Jewish history. Yeah.
Yeah.
All right. Trig functions. There are 6 of them that you may have learned in your geometry, but some geometry teachers only gave you 3 of them, okay? Some of your geometry teachers only talked about the sine, the cosine, and tangent. I would hope that they at least showed you that there's more than just those 3. I think my next slide might have the other 3. No, I don't even have them here either. Oh yeah, here they are. I was looking at it weird. Cosecant, secant, and cotangent. Now, notice the letters he's used. Not all of you may have seen that representation, but where does it come from? It comes from that unit circle that we just had, not necessarily a unit circle in this case. You got this horizontal, you've got this vertical. I will go ahead and make my, let's see, I'll put my point right here, just to show you, it doesn't matter where the point goes. I go here, drop it down. This is my X value. This is my Y value. That's a right angle. This is my R. And can somebody tell me why he said that sine of this angle right here, that sine of this angle is Y over R? Is that what he wrote? Let me see. Yes, he did. Why? Can I have those words again, please?
Opposite over hypotenuse.
Yeah, you had that in geometry. Nice job. Put your points. Now that she gave it away, I bet you everybody's going to remember what cosine meant. Cosine of theta, he said, was x adjacent over hypotenuse.
Opposite over adjacent.
And tangent was,
Opposite over adjacent.
what are the letters?
TOA. T-O-A.
Well, yeah, but give me the, what am I put here? X over R, Y over R, X,
Oh.
Y over X. That was opposite over adjacent. Well, where am I getting the other ones from? Do you remember? Did your teacher cover that? It's possible they didn't.
Goldies.
When I talk about cosecant, what does it look like over there when he, look what he did. What did he do compared to sine? Can anybody see it? What? Yeah, it is. It's called the reciprocal. By George, you got it. Add your points to yours today. He took sine and he flips it and puts this cosecant of theta of that same angle here will now be the hypotenuse over the opposite. Hypotenuse over the opposite. And the cosine flips to make secant. So that becomes that's R over X, which meant adjacent over, it meant hypotenuse over adjacent. And last but not least, tangent flips, becomes cotangent of theta. Instead of opposite over adjacent, it was adjacent over opposite. Whoop, I got to put the letters. X over Y, that was adjacent over opposite. So that's where they all came from. Now, he really goes into some detail about, be careful, Y can't be 0, X can't be 0, Y can't be 0. Of course, we know that, and they did it for tangent too. X can't be 0. You and I both know that the denominator can never be 0. The denominator cannot be 0. So he's just being detailed, which is fine. What do we say? What do we say if the denominator is going to be 0? What word would you give that? Like for instance, say it again? Undefined. Is an error in the calculator. We call it undefined. I like that. Example 1. Finally, we get to do an example. He says the terminal side of an angle that's in standard position passes through a point 815. Find the values of the 6 trigonometric functions of this angle. So if I was to draw my axes and label that ordered pair 8, 15, I need to pretend that it's on a circle. That it's on a circle, okay? I'm only doing part of the circle because I don't care about the rest of the circle. Does that make sense? So if I drop this down and make my triangle like I did, at least I'm in quadrant 1. Would you agree?
Yes.
So in this picture, what value would be x?
15.
8. What value would be y?
15.
Very good, 15. The hard part. What's the value of r?
R equals square root of 8 squared plus 15 squared.
That's absolutely true. R equals the square root of x squared, which was 8 squared, he said, plus 15 squared. Do you have some answers for that? That would be the square root of 64 plus, what's 15 squared?
Is 225.
Oh, 225? And that gives me how much?
289.
Square root of 289, which is
17.
exactly? Oh, beautiful. 17. I might even actually label that as 17 right here to keep myself honest. So we said x was 8, y was 15, r is 17. So do we have all the numbers I need to put in those formulas? Let me hear it loud. Let's scare B-Day to death. That you're going to tell me what to write. Here's my angle, right here. Sine of theta is, I want to hear it loud.
15 over 17.
That was not very loud. My chihuahua can talk louder than that. She really can. She says, I love you, and she says, I want to go outside. And it actually sounds like, I want to go outside. Okay, she wants to go outside. Come on. Cosine of theta is, let me hear it loud.
15 over, oh wait,
8 over 17.
Okay, that was a little better. 8 out of 17. Tangent of theta.
15 over 8.
15 over 8.
I need to hear all at one. 1, 2, 3.
15 over 8.
A day is going to scare B Day. Actually, they might be laughing at you. Cosecant of theta is going to be, real quick.
17 over 15.
The only guy that knew it was a flip got the answer right. The-
No, bro. I was like, did I say the right answer? Like,
Yes, I know. You were like, they left you hanging all by yourself.
like, did I get the right answer? Like, help me out here. You know what I mean?
They didn't even back you up. They just left you out there to dry. Secant of theta.
17 over 8.
Cotangent of theta.
8 over
8 over
15.
15.
Okay. How hard was that? What was the hardest part about that problem?
The math.
It's all math. Duh. The math. Which part of math? The what?
It wasn't that hard.
What was the hardest part though?
Just like figuring out to flip it, I guess.
Oh, the flipping? Okay. All right. I'll buy that.
Maybe like, I don't know.
I was thinking maybe finding 17 might have been the most math we had to do. And then this stuff that we're doing, since you had that in your geometry class of opposite over adjacent and an opposite over hypotenuse, hopefully you don't have to, hopefully you're not learning this for the first time.
Wait, why is cosecant 17 over 15 here?
It's the reciprocal of sine.
Oh, so C is the reciprocal of sine, not the reciprocal of co. Sine.
No,
Yeah.
no,
It's right
no, it does, cosine is not the reciprocal. I got a secret for you. It's actually complement. It's why it's called sine and cosine. They're actually complement of each other. That's later on.
Okay.
But you're onto something, Claudia. You're onto something. All right, let's move on here. Check our work. Did you know the answers because you just looked at the next page?
Yes, sir. No,
Oh, cheaters. Cheaters. All right. No problem. The terminal side of theta, angle theta, is in standard position, passes through the point -3, -4. -3 is here. -4 is here. When you draw your triangle, you have to realize that the angle went from the standard position. It says that right here. That means the angle had to go all the way around and it landed on this spot right here. Okay? That angle went all the way to here, making that angle here. See what I'm saying? The angle opened up, creating that angle. So we're at that ordered pair. So we're basically looking at this triangle. Your triangles that you make are always perpendicular to the x-axis. That's another hard part. I've seen people do this. They had this thing here. They knew this. Then they went like this. Watch this. Don't do this. This is what they do. They go like that.
That's parallel.
Yeah, we don't want that. That right angle's in the wrong spot.
Do I get a star?
But you didn't tell me parallel to what?
The x-axis,
As opposed to?
the y-axis. Being perpendicular.
Oh, okay. Now you're worth the point. Make a note.
Just one.
I don't know. Depends how I feel.
It wasn't that hard. So
Are you feeling lucky?
I'll just put 0.5.
I just want you to put a comment on your paper what you did to participate, and then later on I decide how many points I'm going to give you.
Okay.
Sometimes they get more points than others because what they said was like, wow, I'm so impressed that they came up with that at that moment. All right, so I need to label some things. What would you label X in this picture? Negative what?
3.
-3. What would be the Y?
-4.
-4. What's the R? Is it -5? No. +5. Did anybody remember the 3, 4, 5 triangle?
Yes.
One person. That's 3, 4, 5. If your legs are 3 and 4, the hypotenuse has to be 5, without even doing Pythagorean theorem. But most of you are going to have to do it. You're going to have to go -3 squared plus -4 squared is r squared. R is the square root of 9 plus 16. R is the square root of 25. R is 5. But if you memorized it, it's still just as valid. Here goes. I hope you're not cheating. Sine of theta is.
-4/5.
I am so happy that you did use the -4/5. Even though I know all the answers are, well, the answer's not in the next slide, that's for sure. Cosine of theta, negative what? 3/5. Tangent of theta. And why are you going to leave both negatives?
Nobody can sign, so it's positive.
4/3. You're gonna find out that in the third quadrant, tangent is always positive. You're gonna find out that sine is always negative and cosine is always negative in that quadrant. You're gonna realize this pretty soon. That helps you get check your work. Cosecant of theta must be. Does it matter where the negative goes? I'll still put the negative on top. Not that it really is a -5 because radius is never going to be negative, but it doesn't matter. Oh, cosecant. And secant of theta is -5/3. Cotangent is +3/4. That's right. Okay. You guys are cooking with gas now, guys.
Yeah.
Yeah. So there's all the work. I know you aren't cheating. And if you do cheat, as long as you're learning something, and it's not a test cheating. What he's doing here, example 3. Oh, that's a different problem. I don't know why I didn't delete the work here. I'm not sure what happened. Find the 6 trigonometric, because I have to do edit the PowerPoints and I delete all the work and leave a blank problem. And then I give the work later. Find the 6 trigonometric function values of an angle of theta. It sounds the same, but this time he says the terminal side of theta is defined by x plus 2y equals to 0. If that's the terminal side, he just gave me an equation of a line. If you were a smart person, you could solve that for y and realize that y is equal to, help me out, I need a smart person. Say it again. Negative 1/2 x. Negative, is that what you said? 1/2? So the slope's a negative halves. In other words, what he's saying is you could pretend that this line is just goes on forever, right? But he doesn't want this part that I just drew. He doesn't want that part. He just wants the angle that makes up to the line in this 4th quadrant. This is quadrant 4. So that's kind of interesting, because then he does say he wants that angle. So the point is, he didn't give me any points unless you looked at the picture. I accidentally left the picture. I would have deleted it. So let's pretend that's not there for a minute. What point could I use?
2, negative 1.
You can use, because that's what he had. Is that the only one?
No.
So let's use a different point. Don't use 0, 0.
3.
Because 0, 0 doesn't make an angle.
So negative 1.
You know which one?
Oh wait.
Give me a point.
4,
4,
2,
negative
4, 1, 2, 3, 4.
negative 2.
Negative.
Are you doing it because of the picture again?
No.
How would you do it without the picture? If you say x is 4, plug it in. 4 plus 2y equals to 0. 2y is a negative 4. Y is a negative 2. Is that what we have? That's what we said, right? So yeah, you would have to use your, I mean, he just said use any point with the 0, 0, except from the 0, 0, he ended up using this ordered pair. We're using a different one. We're going to use the 4, negative 2, because it didn't matter. It doesn't matter if the circle's big or the circle is small. It doesn't matter. Trig is trig. It's going to work out. So if I have that angle here, and I'm using this point 4, negative 2, is that what you said? Yes, no? What's the x? What's the y? Nice, I'm glad you said negative 2. What's the r? R squared is square root x squared plus y squared, r squared. No, I'm sorry. R is square root of how much?
16.
Just a 16
Plus
plus a what?
negative 4, right?
Nope,
Oh, yeah, 4 and 7.
because a negative times negative is positive. So it's 4, which is a square root of 20, which turns into, you can use that if you want, but it's not simplified. And you know, when you get to calculus, we don't care. But pre-cal, we do. That's the same thing as square root of 4 times square root of 5, which is 2 square roots of 5. 2 square roots of 5 is your hypotenuse. Okay, the hard work is done. Sine of theta. Now, mind you, this is interesting. We used a different point than he did. The question is, are we going to get different answers?
I have a question.
Yes.
How'd you get 4, negative 2 again?
Well, they decided to pick x as 4. We can pick any x you want. It's on the line.
Okay.
We plugged it into the equation. The equation was x plus 2y equals 0. Or you could say y equals to, let's see, y equals to a negative, that don't work. We plugged in x as 4 right here. We solved for the y and got a negative 2. We could have used any x except for negative x's because they want the angle being in this quadrant here. Okay? So I should have made you pick x is 10. That way you're not cheating and looking at a picture because you cheated. But anyway, I think we're going to be okay. Sine of theta for this situation. I still need x over r.
Maybe -2/2 square root of 5.
X is negative? Oh, am I wrong?
No, not X.
I don't use x. I use what?
Why?
Y, thank you. That's why you're correct and I was wrong. It's a -2 over 2 square roots of what?
5.
And does that simplify? They both have a 2 in it.
Okay, so
-1 over square root of 5. And I'm going to go one step further because I don't know what the author did, but your Algebra 2 teacher did not like you leaving your square root in the bottom, so he also rationalized it. I personally don't care, but Math Lab probably does. How do you remove that square root? We did this in college algebra. What is that system called? What am I doing? What was the process called? Starts with letter R.
Rationalizing
Rationalizing the what?
denominator.
Denominator. So the best answer will be a negative square root of 5 over what?
Over 5.
Over 5. Interesting. Let's do cosine of theta. That would have been, that would be x over r that I was jumping the gun. What's my x? 4. What's my r?
2 square root.
Still 2 square roots of 5. Can that simplify? Don't they both have 2's in it?
Yes.
So what does it leave me?
2
Over square root of 5. And I rationalize it? What does it become?
2 square root of 5 over 5.
Perfect. Tangent of theta would be my y over x. That's harder, isn't it? What's my y?
-2.
-2. What was my x? 4. That reduces to what? Perfect. You're doing good, guys. You're doing really good. Let's do cosecant of theta. Yes, you may. Now, when you do that, guys, do you want to flip this last answer? Or can you flip the first answer we had? Or the second answer? And tell me why I'm asking you that. If you flip the last answer, you're going to have to rationalize the denominator again. If you take this one, it's already rationalized, because what would be -1 over square root of 5 become?
Square root of 5 over
Exactly, which is negative square root of 5. If you choose to flip this one, it'll still work. You just have more steps to do. It's up to you. I'll show you. If I choose to say -5 over the square root of 5 is the answer, then I'm going to have to rationalize this denominator. Look at this, rationalize it. Now it becomes -5 square roots of 5 over 5. The 5's cancel, leaving negative square roots of 5. If I chose the answer before I rationalized, then I don't have to do that. I don't have to do all this extra work. But you get the same answer though. So don't fear. It works no matter how you do it. All right. Secant of theta. I'm going to take which answer? The last answer or the middle answer? Take the middle and flip this one. Square root of 5 over 2. Cotangent of theta. You don't have a choice. Answer is? -2. Now, let me remind you, we chose a different point on that line than the author did. Let's look at his answers. How far off are we? Did we get this for sine? Did we get this for cosine? Did we get this for tangent? Well, how is it? working out that we got the same answers. Uh-oh. Oh, finally. Remember I lost my pen cap one time? And it took me, I had to go and buy them off eBay. Michael found it or something. The Apple tip kept loosening up all the time. This is the first time it actually loosened up since I bought my new one. Oh, it's still not working. Oh, yeah, because it moved. How is it giving me the same answers if I'm at a whole complete set of different numbers? Ratios are ratios.
Because it's on the same line.
It's on the same line. It's still ratio. X over Y and Y over X is always the same no matter where you are on the line because it's similar triangles. You see what I'm saying? It didn't matter that the line was up to here, that triangle, or I went all the way down to here. It's still a similar triangle, guys. Proportions are proportions. It still works. To me, that's like mathemagic. You know, it's like, wow. I wouldn't have thought into that. Okay. Another one I didn't erase the question. Got it. All right. Ignore the answers. Let's do this. Find the values of 6 trig functions for the angle of 90 degrees. I'm going to do it over here without looking. Don't cheat. Angle. 90 degrees. There's my terminal side. Opening it up to here. 90 degrees. There's my angle. And did he give me any restrictions? He did not. So let me share a secret with you. Here's my big secret of the day. When you are at the 90 degrees, I'm going to choose any point on that line, vertical. The easiest point to choose is 0, 1. Why not? Why don't I just go up 1? If I'm over here on the 180 degrees, I'm going to choose -1, 0. Are you listening? Where do you think I'm going to choose a point on the 270 degrees? 0, -1. And what am I going to choose in this at back to 360 or 0 for that matter? 1, 0. The radius will always be the same. What do you think the radius is of this circle? Just take a guess. Here's the center. What's that radius? What's that radius? What is that? What is that? 1. The radius is always 1. It's a unit. Even if I go over here, the radius is still 1. This is called a unit circle. Unit means 1. I'm giving you some advice. Memorize this. If you at your unit circle, this is what's really super cool. We're doing the 90 degrees. Then this is my X. And this is my Y. You see that? If I'm over here at the 180, this is my X. This is my Y. What is R? R's still a 1 here. What is R over here? If that's my X and Y, what's my R? 1. What's my R over here? 1. This is my X. This is my Y. Now that you know where all your X's and Y's are, and R is always a 1, look how easy this problem is. Sine of 90 degrees. That's my angle. He said 90 degrees. There it is, 90. What's the sine of 90 degrees? Y over R. 1. 1 over 1. What's my cosine of 90 degrees? X over R. 0. What's my tangent of 90 degrees? Say it again. How'd you know? Did you cheat? Nice job. He said 1 divided by 0 is undefined. Cosecant of 90 degrees. Ooh, This is 1 over 1. If you flip it, it's still a 1. Absolutely. Cosine of 90, or no, I'm sorry, cosecant of 90 degrees. Be careful. It's 0 over 1. If you flip it, you get what? 1 over 0, and that is what? Undefined. Now watch this. Cotangent of 90 degrees. What happens if you flip 1 over 0?
Oh no,
No, 0.
0.
If you flip 1 over 0, it becomes 0 over 1 is 0. Yes, ma'am. Michael is back. Who else is gone? Just Michael? Okay. So, my secret for this, guys, here's my secret. I usually sell this. That all the answers are in here. Because the first number with x has to be your cosine. The second number, y, has to be your sine. Always. Because your denominator is always a 1. Your radius for sine and cosine. So all you have to memorize, I'm going to trick you. I'm going to jump down to 270. What's the cosine of 270 degrees? This one's my cosine. It'll be 0. What's my sine of 270 degrees? -1. Now the hard part is to do tangent. Tangent is always y over x, y over x, y over x. So if I ask you for tangent down here, -1 over 0 would be undefined. If I ask you for cotangent, cotangent is x over y. That'll be a 0. If you memorize that trick of a unit circle, I'll probably give you one of these big unit circles so that whenever anybody asks you, like we're going to work on 180 degrees, and we're going to go to 180. All you have to know is what that ordered pair is. -1, 0. So if I ask you real fast, what's the sine of 180 degrees? You're going to tell me what? One person got it, huh? 0. I thought maybe the bell's going to ring, but no, we should all be alert. Because that's my y. It always is a sine. What's my cosine of 180 degrees? It'll be a -1. Should you memorize your unit circle? I'm telling you, yes. If you memorize every one of these, all right, tangent of 180 degrees, y over x, y over x, y over x, y over x. 0. And then, I'm not going to do reciprocal this time. I want to think about it. Cosecant is the reciprocal. I guess I will talk about it. What's the reciprocal of 0 over 1?
1 over 0.
Which is? Undefined. What's the reciprocal, I'm going to do a secant of 180. What's the reciprocal of a -1 over 1? Still a -1. What's the reciprocal of 0 over 1? Undefined. This is big stuff. It sounds easy, but it's not. Because you're going to forget these. So if I were you, I would just make a unit circle on a big piece of paper until I give you one. Put all the 4 points that are here and label it 1, 0, 0, 1, -1, 0, 0, -1. And what I would do underneath those, I would write cosine, sine, cosine, sine, cosine, sine, cosine, sine. And I'm going to make one stretch that has not been taught yet. I'm going to give you another secret, that tangent of theta is always equal to sine over cosine. Always. Tangent is equal to sine over cosine, which just meant y over x. If I'm telling you that that means cosine and that means sine, and I'm telling you that that's my x and that's my y, that must be y over x. So if you could graph that picture like in 5 seconds on a piece of paper, if those angles came up and you don't remember what they are and then you can't use your calculator, you could always have your picture and visualize that. I hope that by the end of the year, you're not picking up a calculator to do the sine of 90 degrees or the cosine of 270. What's the cosine of 0? Do I need to grab a stick? Cosine of 0.
Is it in degrees?
1.
It's a 1.
What?
And what if I ask for tangent of 0? 0.
Undefined.
No, tangent was fine.
1.
Cotangent's undefined. Gotcha, Danielle. Because tangent is always sine over cosine. And so if your sine is 0, then 0 over 1 is still a 0. How may I trick you? I want the tangent of 360 degrees. Where's 360?
0.
The same place as 0. So I tricked you. Okay? Questions on this difficult topic? Find the 6 values. All right, so what is he doing? He is just jumping me to a point -3, 0. I wonder if I don't have to do any more work. I wonder if you could tell me what the answer might be. This is not a unit circle now, so you got to be careful. This ordered pair is -3, 0. So this time there's a little problem. What is the radius of that circle? 3. No longer is the radius 1. I wonder if that plays a part in my answers. Do you think? Sine of theta. That's my angle. It's a big angle. Went all the way out to here. That's my angle, whatever it is. Theta is 180 degrees. It's still y over r, but in this case, y is still, check it out, still a 0. 0 over a 3 is still 0. Interesting. Wasn't the sine of 180 also 0? It's still 180. It's still the same angle. Would it matter what point I'm at? It didn't seem to matter. It's still the same angle. Cosine of theta. Does that make a difference? In this case, it does. It's a -3 over -3 over 3, which is, wait a minute, wasn't that the same answer as a unit circle? Which happened after I simplified? So what do you think my point is? If you learn the unit circle, it doesn't matter what point we use on the axis. The answers are all the same. You don't have to memorize that if you don't want to. You can always do the work. But I am trying to give you secrets, mysteries of mathematics. How about the tangent of this angle? Which, by the way, is still 180 degrees, my friends. Take a guess. Let's see if it works. Tangent is y over x. 0 over a -3. They're all the same 3 answers.
When do we not use
When it's not on the axes. When all my dots are somewhere on the axis, those are called quadrant angles. They're on the middle of the quadrants. They're dividing quadrant 1 with quadrant 2 and so forth. This really are for special angles that are on the axes.
So,
Yes.
so for like sines, is O over H, right?
Say it again. Sine.
Sine theta is O over H. Opposite of.
Yes. Yes. Oh, I remember that. Soka Toa was that Indian chief that invented trig? Yeah.
You forgot the H.
You forgot the H in the so.
Somewhere. Where's it at?
So,
And,
T-O.
and it's
S-O-H.
S-O-H.
Oh, S-O-H.
And then
And
C.
C-A-A.
S-O-H-C-A-T-O-A.
C-A-H.
Spell it out.
O.
S-O-H-C-A-H-T-O-A. Okay. Yeah, that chief will roll over in their grave if I spell their name wrong. Chief Sokotoa. Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse.
So,
Tangent, opposite over adjacent. Yes, it works.
so opposite over hypotenuse is the same thing as y over r?
On a unit circle. Well, actually, on any circle, centered at 0, 0. Yeah, it is true. If you make that mental connection, then suddenly you go from just memorizing to understanding about that relationship. But it always is true. It actually is true for other special triangles too. Right triangles have the same thing. We talked about that 30, 60, 90 earlier today. 30, and that's a 90. We do the same thing. If we're talking about the 30, this becomes the O. This becomes the H. This becomes the A because it's next to it. That's opposite, adjacent, hypotenuse. So it still works there too. So those memorization is still very valuable. I won't do the other three because we've done them already. Let's see. Amazing. They're all coming out to the exact same answers. 3 out of 0, undefined. We would have guessed that. The -1, the 0, the undefined code. Beautiful job, yeah. Conditions for undefined. Well, come on, guys. We've already had it. You figured it out. When are my functional values undefined? What happened? The denominator became what? 0. He's talking about some fancy stuff. He's just telling you which ones are undefined. You know? Well, tangent has undefined problems because tangent can be undefined because it has a x or a y in the denominator. Cotangent can be undefined because it has an x or a y in the denominator. Those could be 0. Sine can never be undefined because the denominator is always hypotenuse. Hypotenuse always has to be bigger than 0. True? And the hypotenuse of a circle is that radius. It's always going to be a positive number. So we only have problems with secant, cosecant, tangent, cotangent. They could be undefined. I gave you a blank slide here. I created it myself. Don't you love it? Remember what I said? Make a note to yourself about those quadrant angles. This is for you. Please fill it in with as much information as possible right now. With the points and anything. Fill this in right now. I should have given it to you gigantic. That way you could have had but it's small for you. But you fill in everything you know. Take a couple minutes. Michael, you too.
Yes, sir.
Fill in the unit circle. Because I think if you do it yourself, it'll be more valuable. And then on the side, once you fill it in, do all the trig values. Now, does it matter how big your radius is? Doesn't matter. You can make that radius as big as you want. If I were you, I'd make it the size of 1. Make it simple so you don't have to simplify. All right, take a couple minutes. I want that in your notes. I'm not going to do it because I spent all that time drawing that circle. You know me, I'm not artistic. And look at that's beautiful. It's almost oval, but I won't tell. I wonder how much farther I'm going to go. Let's see. Put your trig functions next to it on the side, all 6 of them. Put your memorization techniques to try to memorize what happens when you're on those boundaries.
Thank you.
Oh wait, there is a symbol.
He's just saying that this is singing.
I think it doesn't matter what points we use, right? It doesn't matter the distance and the.
What?
It's 1, 0, like the radius is 1. There's 3.
The radius is 1.
It doesn't have to be the one, right? It could be any.
Yeah.
So can this be the width? This is it going to the last, right?
So depends which one you're doing.
Yeah, that's right, yeah, that's what I
That
said.
for
That, this one. would
Any
be-
questions?
Yes. So,
Yes.
you don't have to use, like, you can be any distance on the axis,
You
right?
can. You can. Because remember, once you simplify the ratios, they come out to the same answer anyway.
Oh. Okay.
I just think using the unit circle, the 1 radius, is just simpler. Nobody's ever going to ask you again after this section, what is the sine of an angle made when the point is at 0, 5? No one's ever going to ask you that. They're going to ask you this: what's the sine of a 90-degree angle? Because that's the angle it makes,
Is this
and that's more important.
Is the sine of a 90-degree angle different from the sine with a 180-degree angle?
Yes, because the sine of 90 would be the y value, which is 1. The sine of 180 would be the 0. So that's when you start visualizing it. Look how many trig functions you'll have memorized by the end of today. You'll have 6 times 4. You'll have 24 trig values already in your head. You'll have 0 and 90 and 270 and 360 if it comes up. Nobody uses 360. 0, 90, 270. And then you've got the sine, cosine, tangent, cosine, cotangent. You know, you got all those. So that picture alone, if you can memorize it today, is really going to save your life on so many problems in the future. Because you'll just you'll know it. You'll visualize it. I don't have to use my calculator. Speaking of calculator, though.
Sir,
Yes.
can you just briefly go through the unit circle?
You want me to do my sketch?
Yeah, it's not gonna be my.
All right. If I was doing this for me, so I can start memorizing it, I'm going to put some points.
Is there any like chance you can screenshot and put on the remind?
You want to do what?
Can you put this on remind?
The-
Like send a picture of your
I certainly can.
Like in case we run out of time.
Yes, but I'll give you one already completed,
Oh, okay.
nice and pretty, not with my handwriting. So I'm going to call this 0 degrees. I'm going to call this is what happens at 90 degrees. No food. Over here is 180 degrees. Down here is 270 degrees. That's how I know what I'm dealing with. And so the ordered pair here is 0, 1. Ordered pair here is 1, 0. Because I went 1 to the right, 0 up. This one, I went 0 to the right, 1 up. 0 to the right, 1 up. This one, I went 1 to the left, 0 up, so that makes it -1, 0. Coming down this way, that's 0 to the left, but 1 down, so that becomes 0, -1. I've learned that the first number stands for, this would be the cosine of 90 degrees right here. This would be the sine of 90 degrees right here. Doesn't matter where that point is. This one would be the cosine of 0 degrees. This would be the sine of 0 degrees. Over on the left, this is cosine of how many degrees? 180 degrees. This is sine of 180 degrees. This one would be the cosine of 270 degrees. This one must be the sine of 270 degrees. What am I missing? I got sines, cosines. What else do I need? Well, let's talk about secant. I'm not going to write it. Let's jump and do 90 degrees. Secant of 90 degrees. What would I do with secant of 90 degrees? You look at the cosine and you flip it. When you flip 0 over 1, what do you get? Undefined. So I'm not memorizing it. I'll be honest. I'm not memorizing it. I'm memorizing this one. And I say when I do secant, I'll just flip this one. And every one of these numbers, every one of these has a divide by 1, divide by 1, divide by 1, divide by 1. But I'm going to keep that in my head. So if I ask you to give me the tangent of 0, what would I say? Sine over cosine.
0 over 1.
Which is 0. But if I ask you for cotangent, then I got to flip that. That 0 over 1 becomes 1 over 0. So cotangent would have been undefined. I'm not good at memorizing, so I don't memorize all that stuff. But I tell you what, I can draw this circle in 5 seconds on any paper and do my next 10 problems. I have to still think. I still have to think. Let's do one more here. What's the cosecant of 270 degrees? What would I use? Cosecant of 270. What am I flipping?
-1.
I'm flipping the sign. That's really a -1 over 1. So what's the flip?
-1.
It's also -1. Okay?
Right, sir?
Yes.
So cosecant is the reciprocal of sine.
Yes, sir.
And is there one for cosine?
Secant.
Oh, secant is for cosine, cosecant is for sine,
And what's cotangent?
for tangent.
Exactly.
Okay, so
Those are called reciprocal functions. That's his fancy name in the chapter heading. So I just like to think of flipping. You know, that's what reciprocal means. So really, look how many you've got under your belt now. Is I can memorize my picture real fast. I can make those 4 points faster than the speed of light, and I can answer. We'll probably go to our calculator. We'll stop there. We'll go to the. I just want to talk to you about your calculator, and we're going to sign off to the recording because I'm not going to. Well, there's a chart over here if you truly want to memorize data. You have everything there. Notice they're all zeros, ones, negative ones, and undefineds. If you choose to memorize it from a table, that's your business. I can't do this. But I'll tell you what I can do really well. Any question from this table? I cannot memorize this table. I'm not that good. Other people can do that, okay? But let's go to the calculator. I'm going to stop recording here. We're going to say goodbye to B-Day, everybody. And you go ahead, B-Day, you practice with your calculator and get your homework done because it'll be on my math lab.
Learn.
Learn. Yep, that's what we'll do.